Okay, here we go, starting lesson 2.4. It means we're basically halfway through chapter 2. And today we're going to talk about some postulates that you need to know. And then we're going to kind of look at some diagrams and how things might work in those diagrams based off of those postulates or some other things. Alright, so far we have learned 4 postulates. If you think back to chapter 1, the first one we talked about was the ruler postulate, which basically said that we can measure a segment and we can find that distance by subtracting. And then if we got a negative when we subtracted, remember we did the absolute value to get the actual distance. Second postulate was the segment addition postulate. So as we could add small segments together to get bigger segments. As long as those segments were right next to each other, they didn't overlap, and they had to be in a nice straight line. Then we talked about the protractor postulate and how we can measure angles. And then we did the angle addition postulate. So as long as our two angles were adjacent to each other, remember adjacent, they have to share a vertex, share a ray, and they could not share any interior points. They could not overlap. But we could add two adjacent angles together to get a bigger angle, as long as when we added them together, our answer didn't go over 180. All right? So today we're going to look at 7 more postulates, and the first thing I want you to realize is you do not need to memorize them by number. These ones don't have names, like the segment addition postulate had a name. All right, but I'm not going to on a quiz or a test say, hey, what does postulate 8 say? Okay, it's more going to be a fill in the blank or just a basic understanding. Do you have an understanding of what these postulates say? But I'm going to go ahead and write them out here by number so you can kind of match them up with what's in your book if you want to study them. But the first one is going to be postulate number 5. And the first 4 we learned, even though they had names, we just called them postulates 1, 2, 3, and 4 as well. So postulate number 5 says, through any 2 points, there is what? Alright, and this one you guys probably know the answer to already. We've actually talked about it at times. If I draw 2 points on a piece of paper, what can I draw through them? Well, we can draw a line through them, right? We could draw a segment or a ray as well, but we could draw a line. Is there any other possible lines that I could draw there? Okay, could I draw a second line that kind of came this way and then back down? No, because remember lines have to be straight, so that curves. Okay, there's no other place that I could draw a line that's straight and would connect these 2 points. So our postulate says through any 2 points there is exactly 1 line. That's pretty simple. Okay, nothing complicated with postulate number 5. Postulate 6 is kind of like that same one, but a little bit backwards. Okay, we actually just learned about backwards things. Okay, remember when we did converses, they were kind of like backwards. So instead of saying I'm going to start with 2 points and I know there's a line, this one says a line. So I'm going to start with the line. A line contains at least how many points? Well, it's got to be at least 2. Okay, and those would be the 2 points we might use to name the line or whatever. All right, but it's got at least 2. Obviously, we know it's going to have a lot more because the line goes forever, and there's points all along through here. Remember, all these little spots right here are points. We just don't necessarily name them all the time. Okay, postulate 7 says if 2 lines intersect, then, okay, remember if-then statements, we were talking about those back in lesson 2.3, so this is what an if-then statement. If 2 lines intersect. And remember we talked about how if means it may or may not happen. So it's possible that 2 lines don't intersect. Okay, think about that. What kind of lines don't intersect? You guys remember that from previous class? Right? Parallel lines don't intersect. Later on we're going to learn about another type of lines that don't intersect as well. They're called skew lines, but we'll get to that later. All right, but if 2 lines intersect, then their intersection, okay, we talked about that, that's the place where they intersect, and their intersection is what? So think about that. If you've got 2 lines, and they actually do intersect instead of being parallel, they intersect, where does their intersection occur? All right, well, it's right there, right? What is that? That is a what? Point. Okay? That's it. They intersect at one single point. That's it. Nothing else. Okay, that's what postulate number 7 says. Remember, I told you earlier on in the year that postulates are pretty basic. They make sense. They're not real complicated for the most part. All these make sense. Okay, let's talk about postulate number 8. Through any 3 non-collinear points, there is, all right, let's think about that. Remember, non-collinear means not on the same line. Collinear means on the same line. So through any 3 non-collinear points, so 1, 2, 3. Okay, can I draw a single line through them? No. Okay, so my answer is not a line. All right, what can I draw through these 3 points? Well, obviously I could connect them with a triangle, but that's not really going through all 3 points and extending out. You guys remember what we talked about earlier in the year? We talked about planes. Through any 3 non-collinear points, there is exactly 1 plane. Okay, we talked about that with a tripod. Okay. In this case, the plane of my paper contains these 3 points. If I tried any other plane, let's say I tried a plane that kind of came up and down like this, well, it might hit those 2 points, but it misses this one right here. Or maybe I have my plane kind of coming up and down like this, and it moves down that direction. All right, use my hand again right there. It kind of goes there, but once again, we missed that point up there. Okay, so I only have 1 plane that's going to connect those 3 points. Okay, postulate 9 kind of flips this around, just like postulate 6 flipped postulate 5 around. So postulate 9 says a plane contains at least how many points? Well, it's got to be at least 3. Now, it doesn't just say that though. It doesn't just say a plane contains at least 3 points, because what has to be true about those 3 points? Back up here. At least 3 non-collinear points. And that's important that you understand that in both of them. Those 2 terms are important. Okay? You can't just say through any 3 points there's exactly 1 plane. All right? If I put the 3 points in a nice straight line, okay, let me give you an example of that right here. 1, 2, 3. Okay, so they're in a nice straight line. Well, the plane of the paper contains them, but the plane that kind of comes up and down right here also hits those 3 points. And there's another kind of diagonal plane that would catch them as well. Okay, coming this way. All right, so there's a couple different planes that go through these points because they're on the same line. The points we're talking about have to be not on the same line. Okay? Postulate number 10. This one right here is probably the most confusing one of the bunch. The good thing is we don't use it a whole lot either, okay? But if 2 points lie in a plane, not line, lie in a plane, then the line, remember back up at our first one, through any 2 points there's exactly 1 line. So I have these 2 points, so there's a line connecting them. Then the line containing them, or you could say connecting them, also lies in the plane. Okay, so what in the world does that mean? Well, I've got the plane of my paper again, right? So let's say I put 2 points on here. These 2 points are in the plane of the paper. And then I draw a line connecting them. Will that line also be in the plane of the paper? Or can that line kind of come here, jump off the paper for a little while, and then kind of keep going? Well, that doesn't make sense. Or can the line come through these 2 points and kind of curve and come up off the paper, kind of up toward the camera or whatever? That doesn't make sense. It has to stay on the plane as well. It has to stay on that paper. So it does make sense. It's a little more complicated. The good news is we don't use it a lot. All right? Postulate number 11. This is the last postulate for this lesson. Okay. If 2 planes intersect. Now we remember this is another if then. So if means it doesn't have to happen, but if they do, and we talked about this, what kind of planes don't intersect? You guys remember in the room, we talked about this in the classroom, right? Or even in your house. Hopefully the floor and the ceiling don't intersect. Okay, hopefully the front wall and the back wall don't intersect. If they do, we've got some kind of problem. Okay, so if 2 planes intersect, then their intersection is what? Okay, remember, let's think about that. So look at one of the walls around you as you're watching this video. So you look at one wall, and then maybe look at the ceiling. So that wall represents a plane, the ceiling represents another plane, and look at where they intersect kind of at the top of that wall. All right, it goes all the way across. You see it? Make sure you go ahead and look at it. It goes all the way across from one corner to the other. So it's not just points, it's a bunch of points, and it's nice and straight. So that's a line. It looks like a line segment when we look at it in a room, but remember, planes go forever. So that intersection is going to go forever as well. So their intersection is a line. And remember, we drew that earlier. Okay, remember how we drew planes? Okay. And then we said, okay, here's my other plane. It kind of looks like this. Actually, I'm kind of drawing that pretty bad, to be honest with you. Let me see here. Okay. I'm going to start over because that was really bad. Here we go. There's my first plane. Okay. And here's my second plane. And this kind of comes out here. And then we shaded it a little bit. We shade that one. Okay, but here, that's the key right there. That's that point, or that, not point, that's that line of intersection. And since the planes would go forever, that line would go forever. Maybe shade this one a little bit lighter. Okay, with that line right there. Okay, that's that spot where those two planes intersect. Okay, so that's using our postulates there, and then basically you're just going to learn how to apply them. Now the other thing is that this lesson talks about is using diagrams. Okay, so I'm actually just going to show you a diagram from the book real quick instead of me drawing it all out. Alright, so let me zoom in on this a little bit. And you can copy this into your notes real quick if you want to. Okay, which means pause the video and copy that into your notes. Okay, now what I want you to understand is there's certain things, we talked about this with another thing earlier, there's certain things that you can assume and there's certain things you cannot assume. So first, see this letter H here? Okay, that H isn't near a single dot. That dot up there is B, that's A, that's F. So what does H represent? Well, it represents that point right there. Even though there's not a big dot there, remember, if two lines intersect, their intersection has to be a point. So that point is point H. All right, same thing with this dot, that's E, that one's C, so that point of intersection right there is J, and then D. This kind of bolded capital letter represents the plane itself, plane P. Or we could call it, something like plane ABC. Remember, we use three letters that are not on a straight line to name a plane. And then G is just kind of this letter out here. So what are some things we can assume? Well, since there's no dotted lines showing that maybe this line goes out the back of the plane or something like that, all these points are in the same plane. All right, angle, this line AD is nice and straight, so angle AHF and FHJ would have to be a linear pair, or AHF and BHJ would be vertical angles. You've got other vertical angles as well, maybe like HJC and DJE. Those are vertical angles, so we know they're congruent. This is a nice straight line, so A, H, J, and D are all collinear. We can do the same thing here. C, J, and E are collinear, or B, H, and F are collinear. We can say that line AD, remember you only use two letters to name a line, so line AD intersects line BF at point H. Line AD intersects line CE at point J. Now, some things you cannot assume. It looks like GF and E are in a nice straight line, but we don't know that for sure. Okay, so don't assume that. BF and CE, we don't know if they're parallel. Okay, kind of looks like it, so we're not sure if they're going to intersect, so we can't say they do, we can't say they don't, we don't know for sure. Later on in the year, we're going to talk about how we might figure that out for sure. All right, it kind of looks like angle BHA is the same as angle CJH. Those two angles there, they kind of look the same, but we don't know that for sure, so we can't say that. Maybe it kind of looks like these are right angles here, perpendicular lines. We don't know that. We don't know angle H, angle BHJ, or angle JHF. We don't know if that's a right angle. Okay, those are the types of things we don't know. All right, so don't assume too much, but make sure you understand what you are allowed to know. Okay, and that's kind of one of the things you need to understand with diagrams. All right, and I think that's pretty much it for this lesson. Okay, you know what? I lied. Sorry. There's one term you need to understand, and it's not just a simple term like, you know, right angle. Okay, it's a little bit longer, so let me kind of explain it. Draw out a line perpendicular to a plane. Okay, and I had zoomed in so far with that last diagram. Let me zoom back out here. All right, a line perpendicular to a plane. All right, so here's the definition. First off, the line must intersect the plane in exactly one point. Okay, and then number two, okay, the line is perpendicular. That symbol right there, if you don't know that, that means perpendicular. It's kind of like a big upside down capital T. Okay, that means perpendicular. Perpendicular to every line in the plane that it intersects. Not necessarily every line in the plane that it intersects. Okay, so make sure you got that definition. If you need to pause real quick and get that all written down or rewind a little bit, do that. But I'm going to show you kind of what this looks like now. All right, so let's say that my paper here is my plane. I'll go ahead and draw kind of the typical parallelogram we use for a plane. Okay. Now I have a point right here. And when you draw something going through a plane, what you do is you kind of show that it goes off. And this is kind of hidden back behind. And then it reappears down here. Okay, so it's intersecting the plane in only one point. Now, if there's any line in the plane that it intersects, that has to meet at a right angle. Okay, or maybe that line goes this way. Okay, once again, that would have to be a right angle right there. Okay. All right, you might look at that and go, that doesn't look like a right angle. Well, remember, this is kind of three-dimensional looking, okay? All right, now, what about this line here? Does it have to be perpendicular to this line here? No, because remember, it said it had to be perpendicular to every line in the plane that intersects. This line is not going to intersect this line. And don't think that it's going to intersect right here as it comes farther, because remember, this is going through the plane. So it's kind of more like, let's say I got this, and you can kind of see how this is above it. Maybe if I do it, see how they're going to miss each other like that. So this one's kind of coming down. This one's like right here. They're just going to completely miss each other. Okay, so that's why it doesn't have to be perpendicular. I'll actually set the pin there on the plane, and this one's going to go through it. All right. An example of this right here that you might be familiar with would be setting up the Christmas tree. All right, whether you do a fake tree or a real tree. So this is kind of like your tree right here, and this is that base that it sets in, and you set it in there, and then usually, you know, mom or dad or whoever is kind of directing from, you know, a few steps away, you know, telling whoever's down underneath. In my house, it was usually me that was down underneath. So you're kind of turning those screws or whatever to tighten it up, maybe tilting it a little bit one way or the other, and they say, you know, tilt it to the left a little. All right, that's good, that looks good. And so you get it all done, and they're looking at it from just the front, and it looks pretty good left and right, but then they move around to the side, and it's like, whoa, I didn't notice it was tilting too far back. We need to tilt a little bit forward now. So what we're doing is we're looking at it from one view, maybe this view, and it looks pretty good, but then when we kind of turn this way, it messes it up a little bit. So we gotta adjust that a little bit. So it can't just be perpendicular to one line. It has to be perpendicular to any line in the plane that intersects. Now the nice thing is you really only need to check two lines. So if you're setting up a Christmas tree, you only really need to check two views, right? The view from the front, does it look perpendicular left and right? And then maybe move off to the side, and then does it look perpendicular kind of going forward and backwards? If it does, you're good, you're done. You don't have to check every single possible viewpoint. Now, you might continue to check a few more viewpoints to make sure there's not like a bald spot in the tree or whatever, and if there is, maybe you hide it up against the wall or whatever. But as far as being perpendicular, you really only need to check two spots. Technically, though, it has to be perpendicular to every line. And I could draw another line right here, going to be perpendicular. Another line right here, and it's got to be perpendicular. But you really only need to check 2 of those lines. All right? So, quick review of our lesson. We had 7 postulates. All right? Make sure you don't have to memorize them word for word. You need to answer a question like this. I might say something like, a line contains at least blank. You'd fill it in, 2 points. Or, a plane contains at least blank. And if you just say 3 points, you're going to get marked wrong. It has to be 3 non-collinear points. Or I might say if 2 lines intersect and their intersection is a blank. You'll fill in that blank with the word point. Okay. Also, just real quick, I'm going to go back to those postulates. Remember earlier in the year, I told you I would kind of give you this whole star system where which ones are more important, which ones are less important. So, these ones are probably 2 stars. They're kind of important, but they're pretty easy. Okay. Same thing with this one here. And this one here. This one we hardly ever use. So it's more like a 1 star. And then this one would be 2 again. None of them are super important, like we're going to use them all year long. But these things are going to show up on your test. Okay? Maybe not all of them, but 3 or 4 of them, some fill in the blank type stuff. They're going to show up on your quiz, same type of thing. Understanding how to use them, fill in the blank type stuff. All right? So make sure you realize that you need to know them. You need to know them pretty well. Not necessarily exactly word for word, but somewhat close. All right. So if I ask you something like if 2 planes intersect and their intersection is a blank, make sure you can fill that blank in with the word line. Okay. I get people every now and then want to put point right here, or segment. Okay. It's really a line. So just make sure you have those memorized. So make sure you know these postulates. Make sure you understand what you can look at in a diagram and say, yeah, that has to be true, and that I don't really know for sure, so I can't say it. And then understand that term about a line being perpendicular to a plane. Remember, if you got questions, jot them down in your notes, ask me in class, all right? Because when you take good notes, and then if you ask me a question in class, you can jot a little bit more down as I explain it, and then you can use those notes on that short quiz we have every day, all right? We'll see you guys in class. Make sure you get good notes taken while you watch the video.